All right, what is up, guys? We are doing the Chapter 9 review sheet. We're doing the number 1 here. This is the first review. This was given out on Wednesday. So this is equations of lines, a couple graphing things, and coordinate geometry proofs. All right, so the first one we're going to do here, I'm going to do one of each of these as we move through, just kind of make this video a little bit quicker. So if you have any questions, stop in and we can go over them. All right, first one. Equation of the line, this is parallel to the line and it has to go through point C. So first thing we want to do is identify the slope of this line. If it isn't in y equals mx plus b form, so it looks something like this one down here, you're going to want to solve for y first. So here we can identify the slope. Remember, it's supposed to be y equals mx plus b. So the m here is -5. All right, and then this point we can plug in for x and y equals mx plus b. So y is -2. M is -5, x is 5, and then you have the b that we don't know. Remember, we're not using the y-intercept from this line. Ours is different, okay? It could be the same, but we don't know that until we figure out if this point is on this line contains that point or not. So we multiply through, we get -2 is equal to -25 plus b. We add 25 to both sides, and we get 23 is equal to b. So obviously, like that is not, this line does not contain that point. So we just state the equation, y equals mx plus b. It's y equals the slope, which was -5 from earlier, times x, that should be an x, and then plus 23. Okay? Your other option is to use the slope, point slope formula, which would look like y minus y1 equals m times x minus x1. And you would just plug in. So use the point here. This would be y minus -2, so y plus 2 is equal to m, which is -5, times x minus 5. And that's what that equation would look like. And if you just distribute it through and move this over, you would get the same thing. Okay, this time we're doing perpendicular, and it has to contain point D. So once again, identify the slope, solve for y first if you need to. So the slope of this line is -3, which means our perpendicular slope is 1/3. It's the opposite reciprocal. So make it a fraction if it's not. Flip it over. So if we flip this fraction over, it's 1 over -3, which is just -1/3. And then we change the sign to +1/3. Okay? And we're going to do the same thing. We take y equals mx plus b. We plug in our point. So 2 for y. M is 1/3. X is 6 plus b. We combine like terms. This gives us 2. We subtract to solve for b. Here we get b is equal to 0. And so then my equation is y equals 1/3 x plus 0, or just y equals 1/3 x. Okay? Do the same thing over for this one. For number 5, 6, and 7, we have 2 equations that are provided, and we need to figure out if they're parallel, perpendicular, or neither. Remember, parallel means that they are going to have the same slope. Perpendicular means that these are going to be opposite or negative reciprocals, slopes, and neither is anything else. If the slopes are related, excuse me, they're not the same, they're not opposite reciprocals, than as anything else. And if the lines happen to be the same, careful with that one. Okay, so if you solve and you get the exact same line, that's also neither, because the line is intersecting an infinite number of times, so it's not parallel then. Okay, so first things first, we're going to solve for y here. So we're going to subtract 5x from both sides. Now what I like to do is always put the x first in front of that constant number here. So it's going to be -5x minus 35. So it's in that y equals mx plus b form, by the way. This is not y. I forgot that y there, okay? We'll divide everything by -7. And we'll get y is equal to 5 over 7x plus 5. So the y-intercepts are different, so it's not the same line, okay? And the slopes are reciprocals, but they're not opposite reciprocals. So this one is going to be neither. Okay, if it says to explain, you'll just mention that the slopes are not equal or opposite reciprocals. All right, and that would be a nice explanation there. Okay, same thing for this one, just solve for y, check the slopes are the same, the opposite reciprocals, move on. Same thing for number 7 here too, okay? For number 9, when you're working on number 9 here, what you can identify here is that we want to figure out which of these is parallel. So what our job here is going to be identify the slope of this line and then identify the slopes of these lines and just see for parallel which one's the same. So here, we're going to want to move the 5x to the other side by adding 5x. So this is going to be 2y is equal to 5x, remember put the x first, plus 10, and then divide by 2. And we get y is equal to 5 over 2x plus 5. All right? So the slope we can see over here is 5 over 2. Now these two, number 1 and number 2, you can identify that like these have the exact same numbers here. All right? They both have that 5y and 2x. So what we can see is that when we solve, we're going to get the exact same numbers involved for the slope. If we move the 2x to the other side, we're going to get 5y is equal to 2x plus something, right? We'll just call it a number. And when I divide by 5, I'm going to get a slope of some either positive or negative 2/5, which is not the same as this. So these are both out. So we can go to the next one. We can take a look at number 3. And if I solve for y, right, 4y minus 10x equals 12, I'll move the 10x to the other side first. So 4y, 10x first, 10x plus 12, divide by 4, and then we simplify. Make sure you get it in the smallest terms here. So this is going to be 5x over 2 plus 3. And here we can see that this slope is the same, and so that's going to be the choice I make. For number 10, we want perpendicular, so it's the same type of thing here. Solve for y. So if I move 2x to below the other side over there, I'm going to get 3y is equal to negative 2x plus 12. And then we divide by 3. I get y is equal to negative 2/3 x plus 4. So the slope here is negative 2/3, which means the perpendicular slope is the opposite reciprocal. So this, because the 2 is negative, the whole fraction is negative. Mine should be positive and flipped. So it's positive 3 over 2. Positive 3 over positive 2, right? Don't just switch it and make the 3 negative. That is the exact, those are still the same sign. All right, if we just divide out by the coefficient of the y, you can see that this slope here is negative 2/3, which is actually parallel to the line, not perpendicular. All right, if we divide by 2 here, we're going to get a slope of, we'll go this way with it, negative 3 over 2, which is not what we're looking for. That's the same sign as this one, not the opposite sign. If we divide by 2 here, we're going to get a slope of 3 over 2, and that's the one we're looking for. And if we divide by 6 here, this slope would be negative 2/3, which is, once again, parallel. So we want choice 2. Okay. For number 11 here, we are graphing the inequalities. So we'll take a look. All we need to do for all these is identify the slope and the y-intercept. So for the first line, slope is 2, the y-intercept is 8. So I go up 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Plot a point. And then 2 means 2 over 1. Rise 2, 1 run to the right, up 2 over 1 to the right, down 2 and over 1 to the left, down 2 over 1 to the left. And I get a slope that looks like that. Remember, you can use anything to make a straight line here, even a phone, bus pass, whatever you need. Okay. A little bit varying off here, but you get the idea there. Okay, label our line, y less than or equal to 2x plus 8. And because this is less than, the y is less than, we want to shade all the values of y that are less than this graph. So we're shading down here. Okay. All right, the next one, we'll do the one below it. The slope is 2, the y-intercept is negative 2. So here's 2, negative 2, up 2 over 1 again. And we get a line that's parallel to that line going through those points. All right. And then Same thing here. Stay away from the buttons. Let me get that line. So this is line y is greater than or equal to 2x minus 2. And here we're shading this line up. All right. So right now our shadings are in between those two lines. This one, once again, has a slope of -3, a y-intercept of 3. So I go up 3, put a point. And this is -3, so it's down 3, right 1. Or up 3, left 1. And you can see that it's going through the 2 points that are on those lines already. All right. And so, and if you're having a hard time seeing this graph, I will send out on Remind, okay, a color-coded one. So check that one out. This is less than or equal to, once again, we're shading down here, okay? And then here, same thing. Slope is -3. And once again, if they're not already solved for y, you need to solve them for I first. So -7, we're going down 7, 2, 4, 6. There's 7. Slope's -3, so it's up 3 over 1 to the left, up 1 to the left, up 1 to the left. There's a point on that line we're going through, down, 1 to the right. We'll just keep going here. I like doing all the points because it's easy to kind of know where your ruler, straight edge, phone, bus pass, whatever should be going. And here we're shading up because it's a greater than graph. So you can see basically we're getting this shape right in there is what we're looking for. And once again, this equation is y greater than or equal to -3x minus 7. Okay, so there's our graph. There's our shaded region. So find the perimeter. So when you're doing this one, okay, one thing to do if you're doing from the perimeter is either use the distance formula and you can record those coordinates that you're intersecting on, or you can do your box method, right? You draw a box around this. And we can use the these right triangles that are being formed over here. We can use the legs, all right, to help figure out the length of each side. So this is 2. This is 1, 2, 3, 4. Here's 1, 2, 3, 4, 5, 6. Here's 2. Once again, 2, 4, 6, and then 2 again. So there's just 2 sets of triangles. So these 2 lengths we know are going to be congruent. Those are going to be equal. So really, we just have to do the Pythagorean theorem twice. So if we do the square root of 4 squared plus 2 squared, that's a squared plus b squared, and then the square root, that's going to equal c squared here. It's also the distance formula, right? If you subtract the x's, you're going to get x squared. The 2 squared and the y squared is going to be 4 squared when you do that, y2 minus y1. So this is essentially the square root of 20. And we can actually do simplify it if we want to. It's 2 square root of 5 because it's 2 times 2 times 5 in there. And so this is the first distance. The second distance is going to be the 2 and the 6. So if we want to do 2 squared plus 6 squared, this is going to be the square root of 40. That's 2, 2, 2, and 10. 2, 2, 2, and 5. So this is going to be 2 radical 10 for this one. So what do we know? We know that there's some distances. We know that this one is radical 20 over here. This one is radical 20 down here. This side is radical 40. And that side is radical 40. Those are the distances we have. So the perimeter, there's 2 radical 5s plus 2 radical 10s, which ends up being 4 radical 5 plus 4 radical 10. Or if you don't want to simplify, because it doesn't say you have to, there's 2 radical 20s and 2 radical 40s. And so that would be the perimeter as well. And if you want to just type those in the calculator, if you got a decimal, just type that in, hit enter, and then the decimal should match. The area, okay, is going to be our box method. So what's the area of the box minus the area of the 2 triangles? There's 2 triangles that have the same area, 2 sets of areas. So we just have to find the 2 different areas for the triangles and then double those areas and subtract from the box. So the area of the box here, okay, is going to be 4 times 10. So 4 times 10, which is equal to 40. That's the area of the box. And then the area we'll call triangle 1, right? That's triangle 1 up here. We'll put a 1 in there. That's also a 1. So it's 1/2, and then it's 2 times 4. So this is going to have an area of 4. There's 2 of these, so 2 times the area of triangle 1 is going to equal 8. And then we have area of triangle 2. That's the bigger of the triangles. We'll call that a 2. There's 2 as well. It's 1/2 times 2 times 6, which is equal to 6. There's 2 of these, so there's 2 area triangle 2's, which is going to equal 12. So the total area is just the difference of 40 minus 12. That's sum of 12 plus 8. So add these together to get 20, take it away from 40, and you're going to get 20 units squared. And these should all be units squared as well. You don't have to do the unit squared because there aren't units given. And then just explain why it's a parallelogram. There's 2 options, right? Number 1, first option, what do we do with the perimeter? We just show that the opposite sides are congruent. So we can say it's a parallelogram because the opposite sides are congruent. We can just say the distances are equal. Second option, we can say that the opposite sides are parallel and the slopes here are equal. And we know that from the lines up here, right? We figured those out. So those are the 2 options down there to give you number 11. I'm going to have to stop the video here. I will add a part 2 coming up soon, and we'll finish up the rest of this. So check it out.